In this course, we will use a textbook. The name is Object-Oriented Modeling and Design with UML. It is the second edition, and this picture is a cover of the textbook. And this is a very brief introduction to this course. And so in the name of this course we have the object-oriented modeling. So it means that object-oriented is a very important concept. And so we must know what is the meaning of object-oriented. Actually, object-oriented modeling is a way of thinking about problems. Because if we want to because this course we are learning a modeling technique to develop some softwares, and actually before we could develop a software, we must understand the system, understand the requirements, and we also need to communicate with the domain experts. And after we understand the requirements, and then the developer or programmer will changing the ideas of the domain analysis to implementations. But actually, through all of this process, we need some techniques to help us to communicate with each other. So it means that object-oriented modeling it is a method of thinking about the problem. So thinking about the developing problems. It means we will use some models organized as objects to help us to communicate, to design, and to implement the software. So it means the object-oriented models are useful for understanding the problems, communicating with application experts, and preparing documentation. And it means, for example, preparing the documentation for the requirements, or the documentation for the class design or system architecture, and so on. If we want to prepare this kind of documents, we need to understand, and we need to communicate with each other. Actually, we can use the natural language to communicate with each other, but sometimes the natural language is not a very maybe sometimes it is not precise, and but if we can use some modeling techniques, it means this kind of modeling techniques will is beneficial to understanding the problems better, or understanding the problems well, and also the modeling techniques is helpful to designing programs and databases. And in this course, just now we have seen that the modeling techniques maybe different kind of modeling techniques. There are different kind of modeling techniques, but in this course we will only study the object-oriented modeling techniques. And actually, if we in this course we will present object-oriented notations. It means that we need some notations to cooperate with this kind of modeling techniques, or to implement this kind of modeling techniques. And we also need some object-oriented processes. It means if we obey these processes, we can use this process to help us to designing the software and to to analyze the software and to implement the software and so on. It means in this course we will study some techniques. It means study this kind of techniques include the object-oriented notation and object-oriented process. It means these two kind of different techniques. One is the notation and one is the process, but they all object-oriented, and using this notation and processes, we will be able to analyze the problem and design and implement. So this is the outline of this chapter. And the first is what is object orientation, and what is OO development, and what is OO themes and OO modeling history. OO means object orientation. So the first one, what is object orientation? Actually, the object orientation means that we need to organize the software as a collection of discrete objects that incorporate both data structure and behavior. So, what is the difference with the traditional techniques? Before the appearance of object orientation, there are also some different kind of techniques for modeling the system or to developing the systems. For example, the process-based method. In the process-based methods, the data structure and some behavior they're stored separated or implemented separately, and so in this in the object orientation or in the object oriented modeling techniques, we need to organize the software using different objects, and all of this, each object has its own data and its own behavior. Behavior means the methods. For example, we have some class in the Java. We have some class, and we can use some object for the class, and this kind of the new object it is a kind of object what is mentioned here, and this kind of each object will have their own data and method implementation. So what is the main characteristics of OO? Mainly include identity, classification, inheritance, and polymorphism. So let's see one by one. So identity. Identity means that this structure and behaviors are organized into discrete, distinguishable entities called objects. It means distinguishable entities. It means that each object has its own identity. And for example, we have two different bags in a system, in a software. We need to develop a software to manage this, or manage different bags, or manage different cars. It means that although they are all bags, but we need to be able to distinguish them. It means all of them have their own ID, and the objects can be concrete, such as a fair in a fair system, and a white coin in a chess game, a student in a course management system. And the objects can also be conceptual. For example, a scheduling policy in operating system. It means that objects can be different, can be very different. It depends on the software systems you want to develop. It means if you want to develop a system to manage the students, the objects is a concrete. And but if you want to develop a system, a software to manage the for example, manages the processes, or manages the to manage the operating system. It means that we have different kind of scheduling policy. If we want to manage these policies in this kind of in the system to manage the operating system, so the scaling policies is a kind of objects. And this is examples of objects. This is a table. Table can be an object. A binary tree, a monitor. It is a concrete. A bag, Max bag, brings bag. It means they are two different bicycle. All of them have different ID. They are distinguishable in the system, although they are the same bag. All of them are bags. And the second is classification. It means objects. There are many objects in the system sometimes. For example, if we want to develop a software to implement the online calls of the online calling of taxi, there may be many cars or taxis need to be managed, and we cannot implement or we cannot program for each taxi separately. So we need some techniques to abstract or to group them group them together and to implement together. It means that we need some techniques to help us to save the work save the work of managing this kind of system. So it means objects with the same data structure and behavior are grouped into a class. For example, for the paragraph, for example, in an article, there may be many different paragraphs, but all of them are different paragraphs can be abstract into the same class paragraph. And although we may develop a software to manage the sharing bags. Although there are many bags, but we can group the different kind of different bags into the same class called bag. And we can also, for example, we want to develop software for a library, we can group the books into the same class called book. And a class is an abstraction that describes properties important to an application and ignores the rest. So what does it mean? It means that sometimes actually every time if we want to develop a software, we want to use the software to implement some functions, and this software may involve with many different objects, and for each object they have different properties and different behaviors. But for the current software, we only need to describe those properties that is important to this application and ignore the rest. It means that for the properties that is not important to our system, we didn't need to care much about them. So, for example, in a library management system, for the book, we need the name, author, and page will be important to our software, but we don't. But sometimes the prices are not important to the system. And each class describes a possible infinite set of individual objects. It means for the class book, it can describe infinite set of books. It means we can new different objects for this class, for the book class.